Good evening. So my name is Dave Bennett. I am a senior solutions engineer at Indykite. I spend kind of most of my days connecting with our customers and prospects and talking about their problems. I spent most of my career building identity management systems at large enterprises, and I have a keen interest in graphs and graph databases, and I believe they are a great connective solution for connecting previously disconnected data. So these two things bring my life together sort of at Indykite. And this is Dean Brennan.
Hi, as you said, I'm Dean Brennan. I'm his customer. We work with Rockwell Automation. I've spent the last couple of decades working on vast IoT manufacturing solutions, making stuff talk to each other, and a lot of AI data integration and solutions such as that. So I'm going to let Dave take over here.
Okay, so in my travels, it has been my experience that enterprises have plenty of data, but that data is mostly siloed. Identity information is in one system. Crucial business information is in another system. The elements all exist in the landscape at the enterprise, but they aren't connected. They're not in the same place. We can't sort of take advantage of the co-location. We have identity and IAM systems, provenance and catalogs, and policies are frequently buried in code. Customers frequently want to be able to make decisions based on information that is in other systems. Over the years, I've created many sort of point-to-point solutions that have solved sort of these data gaps. But as time went on and standard protocols evolved, these things became sort of easier to build. But there were still point solutions, and there was no holistic solution available. The reality is, whether it's a human or an agent, we have to sort of manually hop between these sort of data islands to select out data and piece together the knowledge to make decisions. The reality of the enterprise is that context is scattered across a multitude of systems. We've built an excellent sort of systems of record all over the place, but we have neglected a systems of relationships. The meaning of our data is different from the data itself. This fragmentation is the primary barrier to the live data context we talk about. We need a way to assemble that context that is already there in a single navigable truth. Enter the Indykite system of intelligence. Oh, no, same slide. Nope. Yep. Now you can go back. There we go. All right. We have button pushing abilities. All right. Enter the Indykite system of intelligence that brings together multiple sources and adds the missing link of relationships. This is the key of this whole thing. Data can then be used to support flexible policies for decisions, data ingress, data egress. In Indykite, the actor is a rich collection of nodes and attributes. We aren't just identifying the user, but we are identifying full personas. We see the business value of the resource in its full context, rather than just sort of these simple objects. We have multi-dimensional objects. Because the data meaning is linked directly or indirectly, maybe hops away to the resource, the system understands the complete picture. This is where the graph magic happens. Because we're all connected, we can see relationships. If an AI agent is looking at a customer's record, what related data can be surfaced to make the agent smarter, give it better context? Thanks to Indykite's attribute level metadata, we provide trusted context to the consumer, be it a human or an AI. They know exactly the value of the information. Okay, now we go. Okay. Sweet, thanks. Okay, so the knowledge graph is a flexible platform, lends itself to modeling really any business problem. One of our customers has several systems of record, not Rockwell, although they do too, but that represent different aspects of trucks over the entire life cycle. Each system has a piece of the puzzle, but none has the complete picture unto itself. So they're elevating the shards of data from these disparate systems into the Indykite knowledge graph to create the full picture of the data they want to expose and create policies on. A knowledge graph provides more contextual relationships and far more metadata than other systems such as like traditional LDAP or SQL. Where LDAP is limited to parent-child relationships with no metadata, the graph enables you to create complex relationships between objects and metadata and add metadata to those relationships. The knowledge graph is also very flexible to query as compared to SQL. In the graph, everything is a node or an edge. Traversing the graph is much simpler than a SQL self-join, for instance. Graph was born to this variable level traversal. Really enables flexible querying. In the past, we treated customers differently from service accounts or AI agents. In Indykite, they're all actors. We are managing the entire workforce, not just the humans. This is where the system of relationship comes to life. We don't just see that a user has a file, we see that they have consent to use it, that it was delegated to them by a manager, and that they are currently using it for a specific project. These are all important contextual points. When we talk about contextual signals, we're really talking about building context graphs. We can use the graph to model complete decision traces to enable better reasoning and future decisions. Okay, next slide, please. Thanks. Okay, we are looking at the problem of scattered context and how a knowledge graph brings it all together. At its core, the Indykite is where security and compliance are co-located to create a unified foundation for the enterprise. Traditional IAM relies on roles, predefined buckets we hope to fit people into, but the real world is a lot messier than that. A knowledge graph is a tool for organizing the mess. In a graph, true context is traversed and computed at the moment of the request. The data is all co-located. Everything that's sort of important can be brought in. The graph can be mutated easily over time. Graphs are very flexible, just nodes and edges. And so it's very easy to add to the graph or take away the graph or mutate it. Attribute level metadata and trust scoring are part of the context. They are baked into the policies, and as the context changes, so do the outcomes. We aren't just syncing databases, we're modeling them to be a single source of truth, where all the data is connected so it is providing the necessary context. The graph doesn't care whether the actor is a person, a service account, or an AI agent. By using a unified model, we ensure that our tools are governed by the same rigorous policies and provenance checks as our human employees. We aren't building separate security silo for AI. We are bringing AI into the governed, trusted ecosystem.
And this is where I get to co-opt my vendor's presentation and talk about Fix by Rockwell. Fix at its whole is a SaaS provider that Rockwell purchased about 6 years ago. It's been a maintenance solution for 15, 20 years now, and it's easily got customers across 100 different countries. We just know maintenance. I could go into a great deal of what a CMMS is. I'm pretty sure you guys have heard enough of that today. So I'm going to kind of gloss over a lot of what Fix does. But they've focused on how to work for the guy on the shop floor, not some bean pusher that tells us what we need to get done. That's their biggest kind of feature. And I'm going to go into more of what we did working with Indykite that allowed us to really bring the Fix CMMS into the Rockwell ecosystem as a whole. So in Rockwell, they've got a lot of very siloed projects, very common in large corporations that have focused on machinery first. They purchased a bunch of new SaaS providers that have their own ways of communicating. Good example of what Indykite is it became the source of truth for us that we were working with. We jokingly call them our Switzerland. Application A knows how to communicate with application A and knows how to communicate. Application B knows how to do its stuff, right? You'd have to re-log into both effectively to make this system work. What Indykite allows us to do is it's the source of truth. So Dave here, if he logs into application A, Indykite knows he also has access to application B. And so we're able to now go in and query. So if he tries to go from application A, say he has a token for that one, and goes to application B can just quickly connect with Indykite and say, hey, do you know this guy? And he's like, oh yeah, it's Dave, he's fine. And then application B can move on that. So it allowed us to combine a great deal of siloed systems into one, so we had the ability to add a bunch more features that we normally couldn't have connected that way. And that's where it talks about a great deal of our connectivity. So we were going to finally connect with our factory talk optics, so our machine floor connector that was able to bring its data into our cloud-based solution. It allowed us to connect to a bunch of the other interesting silos inside of Rockwell, right? Sorry, now I just got distracted here. My bad. And I guess the biggest thing you guys have heard today about MES is maintenance solutions is the matrix journey, right? Where we are between reactive maintenance, predictive maintenance, there's preventative maintenance, and where you are in that journey. And everybody's agreed today that predictive and prescriptive maintenance is the holy grail that everybody's searching for. The problem is that's if you have all the data from the factory floor brought into the cloud, and it's been an enterprise solution already with fixes CMMS, we have that ability. We have the ability to detect a fault in a machine and create the work order automatically. We have the ability to make all the preventative maintenance in advance. With our AI chatbot, we even have the ability to do some of the prescriptive maintenance, saying, oh, this device needs widget B. But that's for an enterprise client that's been there for a while. The problem that comes with this is how long does it take to create that connection, that getting your system up and running to the point where you have the ability to use such a thing. And that's normally a lengthy journey for enterprise customers. They spend a small fortune on that. Or they have to hire a specialist to be able to go through and connect all the machines to the cloud and all of that. And before working with Indykite, we didn't have that ability to connect all of our various maintenance solutions with our factory talk optics, for example. And this brought up our newest little project pitch, I guess we're working on here right now, that we call Project Rubicon. Basically, once you've crossed this one, that's where you want to go now. Maintenance is a little bit easier in this case because we have an AI tool that allows us to, with a new customer being onboarded, knowing the machinery they have, using our large language models that we've created, make the determination of, okay, this is probably what you want to use with it, some couple quick button clicks, to have automatically the data connected from the factory floor to the cloud, mapped correctly, so immediately your preventative maintenance schedules are created automatically. It can then create the condition-based maintenance required for your work orders to be generated, and a great deal of the other features in minutes, not months. Minutes. And this is really the competitive advantage that we've been talking about recently, working with Indykite. So obviously the benefits, of Rubicon, the cost savings just of onboarding itself, pays for itself. But that's just not the only ability we get working with our large data model within Rockwell and Fix. Because we have a great deal of industry knowledge with both Fix's maintenance solution and Rockwell's, it's Rockwell, let's be honest, their industry solutions as a whole, as well as our AI model, we're able to now allow your junior engineer to become like a senior engineer in the field, right? Because they can just go, well, what's wrong with this machine? And our prescriptive maintenance, our AI chatbot, things like that we're implementing, allows us to say, oh, hey, you have to sorry, I'm not a tech guy. I can't actually answer these questions for you. But our machine can, our system can, and that gives us a huge competitive advantage there. The third is it allows us to sorry, 1 second here. Integrating with our large language model allows for that kind of seamless communication throughout. So we can actually get to prescriptive maintenance, predictive maintenance, versus where without spending that massive cost sink in current dollars. This actually does open up a huge AI avenue for Rockwell as a whole, because now we've got unsiloed systems that can now start using a trusted source to now bring data together and glean more insights from this. I mean, obviously, the holy grail of this is to build true predictive maintenance by analyzing the data from a machine floor and making determinations on when it's going to fail. It allows for cross-selling between Rockwell products now that we didn't have before as a result of the collaboration inside of Rockwell as a whole. Sorry, I'm old. I can't see, guys. In the future directions of where we're going, it allows us to build more robust AI models. So we can actually start going down that entire journey of, oh, this machine's going to be failing in a couple of days or a week or so. But if you go and wiggle like widget 11B, it should repair itself correctly, reducing cost, reducing stress, and greatly ensuring maintenance software is correctly configured. Wow, that time ran down quick. And I would like to open it up, I guess, with you guys some more questions about this, because it's a high-level AI widget that allows us to rapidly progress into a new environment with Rockwell Automation.